Hello everyone. Today I want to talk with you about an algorithm, a machine learning algorithm that can learn how things look without any kind of human intervention. And so my target audience is not people who are well aware or well versed with the machine learning, how it works. No, my target audience is a common person, a person who has no idea of how machine learning works, but I still want to convey this idea till that person. Um, so what would we discuss today is that first I'll quickly go through what machine learning itself means, or not in its not no maths today. No, I know you hate it. Just what it implies, what machine learning implies. Then we will look at how traditionally it was being done and what's new with the without human intervention things. And then I would explain this algorithm, which is by the way named as swapping assignments between views of the same image, or just to make it easier for you, SWAV or SwAV. Let's just call it SwAV. Well, how does does it? What does it do? And then we will look at how this implies for the world and what are the implications of this algorithm. So first and foremost, this SwAV algorithm was created by or used by Facebook AI Research in 2021, and they have it published already. The paper that's called Unsupervised Learning of Visual Features in Contrasting Cluster Assignments. Now you don't have to remember that name; you just have to see that they have already published the paper. They have the code online, and it works. So first, we'll begin with what machine learning implies, and I will give you one example. Let's say you have bought a nice little plot in a small town, and you want to start business there. And because this town is small, it doesn't have a established grocery store, and you want to start a grocery store and also some of the electronics store, like a mix of, you know what I mean. So you want to establish this store, you want to build on it, and you can't be there at this town because you live in a bigger city. You want some other person to take care of this for you. So and you want to train this person, and what do you want to train this person with is that when a customer arrives and he says he wants something, then he should give him that thing what the customer wants, and then charge him for the same, and take the money, and that's how the business should go on. So not a very difficult task, and we humans have been doing it since the start of civilizations. So the thing here, and how what does this have to do with machine learning, is that the what did you understand from this process is that you made this new person, the guy, the shop guy, let's say, that you have hired for this work. You made him learn how things look or what things we have in the grocery store. So for example, he should know if someone orders a mobile phone of this kind with its name, or a mobile phone that's of this kind, or I won't take the names. Or if the customer wants to buy a toy train, then it has to look like this, and we have it or not, he should know it, right? So that's his task. Now, with machine learning, what we can do is that we can replace this person, and we can bring in a computer that can do the same tasks. So that's what machine learning implies. So it will learn on some sort of task. It will understand, it will look at the things you have in your grocery store, and then it will predict something, or it will give the customer something when the customer demands it. So that's how machine learning means, or means to a problem that can be solved. Um, yes. So now we'll look at how this can be done, how you can replace this the person with the computer. Now the computer does not have its own brain, but humans we have. So uh, we need uh, we need the computer to learn what this object, what the customer means when he wants a mobile phone. So what we can do is that we can create labels, like we can label it, this is a mobile phone, and we can just put um, in an Excel sheet that this can be named as a mobile phone, and you have a label now. This is a mobile phone, a bigger mobile phone. But this is a smaller mobile phone, we can say. Or we can say this is a pen, a permanent marker. Or we can say this is some lid, some tin, some lid of some sort of container that the customer has asked of some specific diameter and stuff. Now we can create like thousands of labels, and we don't have to worry because computer has a lot of computing power. Now, um, the way this it was being done so far is that the data that was being fed, or the way it was being done, is by you assign the labels by yourself, by some sort of human. So you see that we are again dependent on humans to do the labeling, so that once we have all the labels inside this one Excel sheet, we can train on it, and then the model will do its work. All right. So this is the way it was being done traditionally, and you see that the problem here would be that we need labeling time and a human intervention, and it also needs cost. So it incurs some cost, because then the person would charge you money. Okay, you're asking me to label, I need some money. Yes, fair enough. And the way there's also one more thing, that if you're tired, maybe it's Friday evening, you're too excited, maybe you're too tired, it's Monday morning, and you're in some mood, or you're thinking of something else, and you accidentally label this mobile phone as a train, a toy train. And now, because I said machines or computers don't have their own brains, it could just think that yes, this means it's a mobile phone, or this means this is a toy train, and which is not the truth. But that's what the machine learning will make the model learn, or the algorithm will learn. Now, to avoid this both things comes in the SwAV algorithm, where we can see that it does these tasks, it does the same task, but it doesn't need any kind of human intervention in it. So how does this algorithm work? The way it works is that it understands how things look by yeah, I can give you one example. Is that let's say we there are like 10, 10 nails hammered into a different section of a wall, or let's say this room, and each of these nails has a thread attached, and there is a marker attached to the end of the thread. Now each of the 10 nails have 10 threads, 10 strings attached to this marker, and when it looks at the object, that is like when it looks at the image of that object, so when it sees that this is a mobile phone, okay, it looks okay, it has some square or sorry, rectangular features, then it would take the marker there to the right. All right, then it looks at this bottle, some sort of bottle, and it thinks like, okay, it has a curvy shape here, and then it has some straight lines here and stuff. Okay, then you get the position here. So the marker is moved here. So each of the thread has pulling or pushing power. And now you can imagine if we do this for all of the images, like, so there are two mobile phones now. And not both are mobile phones, yes, both are kind of similar in shape, but still little different. So in this case, the marker would be like, for the bigger mobile phone, it would go maybe there, and for the smaller mobile phone, maybe here. And once it has, so the point of all this marker and the thread discussion is that the space here, every point in the space has a unique code or unique identity that can be attributed, like that can be attributed to some sort of unique object in the space. Now once we know to generate a code, what the SwAV does is that it creates for the same image, so let's say for this mobile phone, it creates a lot of different augmentations. Now, what do I mean this word augmentations? It you all use Instagram, almost all of you, and in Instagram we have filters that we can make the mirror of the image, or we can create a flip. We can flip the image, or we can change the tint. We can make it solarized and whatnot. So it's the same image, but it has some other stuff done to it, and it looks different now. But it's still the same object. So with the SwAV does the same thing, and for each of this augmented images, it generates a code, and every code that's a unique code. um, this code generated for this mobile phone would be something, let's say 2, and then the mirror image of this yes, so the mirror image of this mobile phone, it would generate another code, so let's say 4. Now we'll do like 4, 5, 6 different filters will apply on it, and one code is being predicted by all the other images of this, all the other filtered images. So the point here is that you establish some connection between the code generated for each image, and it is being predicted by the other codes. So this means that the same object would be clustered in some space, that that all the different filtered images of the same mobile phone have a unique position in this corner maybe, and then another one in this corner, and maybe this train has a different corner. So that's how, what this implies for the marketplace is that, so the next time in your store a customer comes and he asks for, I want a mobile phone, your model would have already learned. It just looks at that cluster there in the corner, and it would just say yes, that's where the mobile phone is, and your customer gets a mobile phone. So it's a revelation. Thank you.